They gave you the current, which is uniformly reduced from 100 to 20 milliampere in 8 seconds. So what is the charge that flows? So to find the charge that flows, remember, originally the formula is Q equals IT, but that's only for constant current. Your current is not constant, so let's draw it out. So from 0 to 8 seconds is dropping from 100 to 20, right? So the whole area under the graph here is your charge that flows. So remember, Q will be area under the graph. So be careful also to go all the way to the horizontal axis. So find the area of the trapezium and you will get the answer. They gave you the current and they gave you 1 hour and they ask you to find number of electrons. So number of electrons means you got to split your current. And anyway, do you realize your current is constant? So your current is constant, so I equals to NQ over T. So N is your number of electrons times the charge of each electron. So you want number of electrons in 1 second. Not only 1 second, in 1 hour. So you take the N as your subject, then you get N equals to I times T over Q. So substitute your current to ampere. Now 1 hour must change to seconds, because your current in ampere is SI. So your time 1 hour also must be SI. So change 1 hour times 60 minutes times 60 seconds and then divide by the charge of the electron and you get the number of electrons. Alright, so for this question, they want to find the rate of flow. So that means number of electrons per second. So you use the formula I equals to NQ over T. So therefore number of electrons, rate of flow means number of electrons per second is N over T equals to I over Q. So the current here is 4.8 amperes and the charge here is 1.6 times 10 to the negative. So that is the rate of flow of electrons, but they also want the direction. Now remember, in my video I mentioned to you, we always take conventional current to be positive to negative because that was a wrong assumption people had last time. Right? So until now we keep to that because it's too tedious to change everything. But we just have to remember electrons are opposite. Electrons will flow from negative to positive. So the direction of flow of electrons therefore is from Y to X. Okay, so when there's no current, it means that the electrons are moving. How? Wrong. They are moving randomly. Totally randomly within the wires. Only when you apply a PD, right, they will drift in one direction, but they cannot be stationary because this is a sea of delocalized electrons which move about the whole metal. Understand or not? So it doesn't vibrate, it isn't stationary. It must move about randomly. They said how many electrons pass through a given cross-section in 1 second. So don't worry, number of electrons basically you can use N over T equals to I over Q. Now, people ask me what about the area? The area can ignore. So the area here is just to trick you only. Okay? So number per second means N over T because N over T is 1 second. So you get 10 over the charge of the electron. 1.6 times 10 to the power negative 19. And you should get C, yes.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with 1 or 2 past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.